Long division of polynomials works very similarly to long division of regular integers. If you remember with regular integers, we would take the denominator of 5 and ask how many times it goes into 4,298. And we would take the front numbers. 5 goes into 40. 40 goes into 42 8 times. And then we'd multiply 8 times the 5 to get 40. We change the sign out front and subtract to get 2. Bring down the next digit of 9. 5 goes into 29 5 times. 5 times 5 is 25. Subtract, changing the sign. 29 minus 25 is 4. Then we would bring down the next digit. 5 would go into 48 9 times, because 9 times 5 is 45. And we would subtract, and there would be 3 left over. Now, we could say that would be a remainder of 3. But there is also an alternative way we could write it as a mixed number. We could say 859, and then we'd put that remainder over the number out front. And 859 and 3/5. Both of those answers being exactly the same, that's long division with numbers. Long division with polynomials is going to be exactly identical, except instead of digits, we're going to work with terms. Long division of polynomials. We don't often divide polynomials, but when we do, we'll often use long division. And the only difference between polynomials and numbers is polynomials, we take one term at a time, and numbers, we did one digit at a time. So take, for example, 4x cubed plus 5x squared minus 3x plus 2. We're going to divide by x plus 2. So the x plus 2 is going out front, dividing into the 4x cubed plus 5x squared minus 3x plus 2. And we do the front terms instead of the front digits. So first, 4x cubed divided by out an x. So I'm thinking 4x cubed and dividing out an x, that's going to leave me with 4x squared. Then just like with long division, we multiply that 4x times the x plus 2. 4x squared times x is 4x cubed. And 4x squared times 2 is plus 8x squared. And now we subtract, which is akin to changing the signs. This is the important step. We have to change the signs all the way through. 4x cubes are gone. 5 minus 8 is negative 3x squared. And we bring down not the next digit, but the next term, minus the 3x. Then we do it again. This time taking the 3x squared, negative 3x squared. And we divide out the front term of x. This time that's going to give us negative 3x. One of the x's divided out. So we've got negative 3x. And we multiply that times the front. Negative 3x times x is negative 3x squared. And negative 3x times 2 is negative 6x. Now we subtract that, which is the same as changing the signs on everything. Don't forget to change the signs on everything before you combine. Negative 3 plus 6 is 3x. And then we bring down the last term. Then we can do it again. This time the front term is 3x. We're dividing out the front term of x. That leaves just 3. It's a positive 3, so we'll say plus 3. And multiply by the front. 3 times x is 3x. 3 times 2 is 6. And then we change the signs. Change the signs on everything so that when we subtract, we get 0. 2 minus 6 is negative 4. There's nothing else to bring down, so we'll say there's a remainder of negative 4. And so we get this solution of 4x squared minus 3x plus 3 with a remainder of negative 4. Now we could express that as a mixed number as well. 4x squared minus 3x plus 3. And then we can do a minus, because the remainder was negative 4, over the number out front, the x plus 2. So some problems on your homework might ask for the remainder of negative 4. Some problems might prefer the mixed number with the minus 4 over x plus 2. Make sure you're reading the directions so you know which format to do. But long division, same exact process as long division with numbers. Just dealing with terms instead of digits. We do need to be careful of one potential trap, though, and that's if an exponent is skipped, we must add 0 for a placeholder, because every digit or every term needs to be accounted for. And you'll notice in this example, 5x cubed minus 4x plus 2, what's missing is the x squared term is missing. So when we set it up, we're going to set it up with 0x squared to hold the place value. That's going to be the most common error on the test, is students will forget to hold the place value with that 0x squared. So now it counts down 3, 2, 1, 0 x's. So let's see if we can take x minus 3 into 5x cubed plus 0x squared minus 4x plus 2. Taking the front terms, 5x cubed and x, 5x cubed, divide out an x. That's going to leave us with 5x squared. And then we multiply by both terms out front. 5 times x is 5x cubed, minus 3 times 5 is 15x squared. Change the sign on both when we combine. 0 plus 15 is 15x squared. And bring down the next term of the negative 4x. And we do it again. Again with the front terms, 15x squared. Divide out an x, that's going to leave 15x behind. It's positive, so plus 15x. And we'll multiply by the front. 15x times x is 15x squared. 15 times negative 3 is negative 45x. Change the sign on both. Very important that it's both. 15x squareds are gone. 45 minus 4 is 41x. Bring down the last term. And now we're ready to finish it off with 41x. Divide out the x, we're left with 41. It's positive, 41. And we multiply out front. 41 times x is 41x. 41 times negative 3 is negative 123. Change the sign on both. So the 41s are gone, and we have 125 left for our remainder. So our quotient, 5x squared plus 15x plus 41, with a remainder of 125. Or if the answer prefers mixed number notation, 5x squared plus 15x plus 41. The remainder is positive this time, and we put the 125 over the number out front, the x minus 3. Depending if they want a remainder or a mixed polynomial. All right, one more example. This one's just to see how interesting it can get. 2x cubed minus 10x squared plus 7x minus 18, all divided by 2x squared plus 5. This one we're going to have to be careful because you notice there's something missing in the denominator. In the denominator, we're missing the 0x. Need to make sure it always counts down So 2x squared plus 0x plus 5 is dividing into 2x cubed minus 10x squared plus 7x minus 18. Again, we take the front terms. 2x cubed divided by 2x squared. 2x cubed divided by 2x squared. The 2's are gone. All that's left is just an x. That's nice. So x times 2x squared is 2x cubed. X times 0x is 0x squared. And x times 5 is 5x. Change the signs on everything. So the 2x squareds are gone. Negative 10 minus 0 is still negative 10x squared. Plus 7 minus 5 is 2x. Minus 18. And now we take the front terms again. This time the front term is negative 10x squared. And we're going to divide out the 2x squared. Well, negative 10 divided by 2 is negative 5, and the x squareds are gone. So we'll distribute that negative 5 onto the entire thing, giving us negative 10x squared. Negative 5 times 0 is 0x. And negative 5 times 5 is negative 25. Change the signs on everything again. Negative 10 plus 10 is 0. 2 minus 0 is 2x. 18 plus 25 is 7. There's nothing more to bring down. You'll notice we can't divide. If we tried to divide the front terms, 2x by 2x squared, the 2's would be gone, and 1 minus 2 is x to the negative 1. We don't want to deal with negative exponents, so we can't go any further. So we're ready to say there is a remainder of 2x plus 7. So our final answer here is x minus 5 with a remainder of 2x plus 7. Or in mixed number form, since the remainder is positive, we'll add the 2x plus 7, putting it over the front number of 2x squared plus 5. And we have our final quotient. Long division takes several steps, but none of the steps are necessarily difficult. So take the time to go through them. Be careful of changing all the signs. Be careful that the exponents count down, and you'll find long division of polynomials is quite nice. Good luck on the homework assignment. Let your instructor know if you have any questions.